So Glenn Vanderveen, I'm with Belshire. I was very flattered to be invited to come talk to you today. My goal here was to say, hey, we do a lot of these inspections every month across the state, and so we're designated operators a lot. And most of our clients say, hey, can you look at some other things too? So if I took everything that we do for every client and lumped it all together, it comes pretty close to encompassing everything that that tank owner's got to do to satisfy what you would look for in a Coupa inspection. So what I was asked to do is, hey, why don't you take that information, take what you do, compare it to the PEI document to see how that matches up, and then where does that fit with the regulations that we have? So how does that all work together? So that's what I'm going to try to do here. Oops. How do I go back? That? All right. So three basic categories: before, during, and after. And the PEI document focuses just on vehicle fueling. So while we have a larger population of tanks, this is really just about the vehicle fueling. And we're going to touch on some vapor recovery. I'm not going to talk too much about it, but it's there. It is part of the PEI document, so we'll mention it. And safety as well. Again, not really what we look at in a Coupa inspection, but it is in there, so we'll look a little bit at that. So preparation, certification. Obviously, to do a DO inspection, you have to have the ICC certification. That corresponds basically with the federal requirement for the AB. Now, the PEI document also has some recommendations for the type of person to do the different inspections that they have, and they have a level 1, 2, and 3. What's important to note is they don't correspond with the federal or the state levels either. So it's, again, you got to sort of think of this PEI document as a recommended practice, and hey, if you're going to do these things, these are, this is the type of person that should do it, but it doesn't really, that part doesn't really correspond. And then, of course, if you're in South Coast, you've got some requirements there. And as far as safety goes, there really isn't much in terms of a certification, but a lot of the industry is looking at this API safety key. So that's one that, and it's not bad for a person doing an audit or an inspection to have. It gives them some sense of what other people that are working at the site might be dealing with. And to me, it's sort of, this is what you shouldn't do. These are things you shouldn't do. You don't have those kind of training, so it helps, I think, with that. And so training, obviously very important for somebody who's going to be going and looking at all these compliance aspects. Safety training, the PEI document really talks about that it's the owner's responsibility to hire somebody who's properly trained. And that sounds right to me. It's the employer's responsibility to make sure they get the training, especially with respect to safety. But there's other parts when you go to do an inspection that you really can't do just because you have an ICC certification, and really, in my opinion, just from reading a book or a manual. You need someone to show you, hey, this is what you do to get an alarm history. This is how you look at a secondary containment test. You got to look at the whole thing. You got to review the different parts of it. I mean, it's something that I think is easy to gloss over if you have a card, but it really requires someone to show you how to do these things. I don't know of any requirement for that, but it's something I don't think you could really do the inspection properly without. And then technical support network, I think is very important. When I think about a DO or a person who's going to be doing something on a monthly basis, they probably aren't going to be VITA certified. They're probably not going to have confined space entry training or a lot of other technical expertise that they might need. And they'll have some sense of the regulations, but they're not going to be, they're not going to know everything. And they need to have someone that they can call, whether it's a contractor that they know, maybe it's an inspector that they have a good rapport with, or somebody. But I think it's really important that they're not out there thinking, I got to figure this out on my own and make a call here and try to, I mean, that's really not fair to the tank owner. They really need somebody to support them. And so, we have people in our office, and I think most of the large companies would have some support in their own offices, but an individual should be looking for, who can I call when I need help? I think that's really important. Okay, and then preparation equipment. There's some safety equipment that's in there. PEI touches on this a little bit. They refer to OSHA typically. This is all standard stuff. I think it's interesting now with steel-toed shoes. They look like tennis shoes anymore, right? I mean, they're not always, you look at someone and go, where's your boots? Well, these, it's different now. But and then leather gloves and hard hat, I don't think you really need, but sometimes out, and especially in the desert when it's real hot, that the lids on the spill buckets get hot, so we carry leather gloves. And then the hard hats, if there happens to be construction going on, often the construction crews won't let us on site, so we carry a hard hat just so we can get on site. And then to actually look at equipment, there's equipment you need, right? You got to open a Fiberlight lid, perhaps. You want to have a lid puller. Those little grabber tools are real handy if you're going to be pulling debris out of a UDC, let's say. It's good to have some absorbent pads in case there's just, those are useful for cleaning spill buckets too, or whatever. If you're going to have labels, we like to assist our clients with labeling. You just got to make sure you know how they're managing their waste, how they label their waste, you need to really be in tune with their waste program. And dispenser keys, those are fun. Just when you think you have them all, there's something new. There's an alarm or a special bolt that's on there that you've never seen before. So that's always a moving target. But you at least have the main ones. And then some kind of a pump. Yes, that's a pump that you can pump liquids out of containment if you need to. And not necessarily that you have to always do all these things, but if you're going to provide that type of service, obviously you have to have that type of equipment. When you're looking at paperwork at these fueling sites, you really you really have to have like your own office. And so like this picture is like is one of the trunks of one of our inspectors' cars, and there's a printer in there, and they've got all their paperwork in a file box. I mean, it's amazing how many of these places don't have 3-hole punches and staplers. I mean, you don't think of that, but you got to have all that stuff to be out there and helping them with their paperwork. Oh, and yeah, internet's nice to have. I mean, we like to transfer documents back and forth. If you can't get something, it's really helpful to be able to receive a fax or a scan from a contractor or somebody else. Okay, so I know you can't read that list. It's probably too small, or maybe you can. But the idea here is establishing the scope. When you think about, if I go to a site and say, hey, I'm going to be your designated operator, a lot of tank owners, especially real small operators, will say, okay, great, I'm done. I'm good now. So that list is kind of everything or topics that I'm going to talk about in some way today. And the part that's pulled out or boxed is the part that the designated operator is responsible to do. And so I think it's really important to set up at the beginning and say, hey, look, guys, this is what we're doing. This is part of the regulation that I'm doing. If you're able to, or if you want to do these other things, you can talk about them, but it's important that they know that, hey, I am not getting your permits for you, right? I am not writing your monitoring plan for you. That's your responsibility. Because I don't know how many times they'll come back and say, hey, I got a violation. Why didn't you do this? Well, it's not what we're doing. So it's really important to go through that stuff. And the RP 900 talks a little bit about it, and they recognize that it's a recommended practice, and so they'll say, hey, look, the scope is going to depend on what the local agency requires, and the frequency is going to also depend on what the local agency requires. And so it's, you can't write a federal document that's going to work everywhere. Heck, you can't even write a state document that works everywhere. Right? So what do we do when we find a problem? So RP 900 says you have to have a checklist. You should agree upon who will address each item. Now, I don't know. They're actually, 2715 says you have to notify the owner-operator when you find an issue, right? So there's some correlation there. But this, to us, is really important. Again, when you're out there every month, there's some expectation that you're looking out for these things and you're taking care of them. And so if I say, look, when we find that your spill buckets are dirty, are we supposed to clean them, or who's cleaning them, right? Who's taking care of that? Hey, you're missing a test report. Are we supposed to chase that test report down, or are you going to chase it down? Really important to figure that out. So anything we go, well, if we have just a straight DO and nothing else, or if we're looking at a whole myriad of other things, we're going to set up and say, look, when we find a problem, what are we going to do? And then we write that down. It goes in a table, and now everybody knows, and we're consistent across the whole program on how we're going to do that. And then a subset of that is, what do we do for different alarms? There's a lot of different alarms out there, a lot of different interpretations on how you respond to those alarms, and a lot of different people might even be responding to different alarms. And so we set up a guide that says, this is what we're going to do for each alarm. This is the person that gets called. Here's how that all works. And that makes it a lot cleaner. It's a little work up front, but it makes it a lot cleaner, especially when you have people with multiple sites, a lot of sites, across the state. And then, escalation. There are some folks who are happy with getting the report at the end of the month, and there are some that say, look, if you find a problem where I have a part of the system that's not working, I need a phone call, I need a live person. I need that to happen immediately, and that's important, right? I mean, if your system's not monitoring, you're obviously at some risk. So this is just a short sample of what part of our response guide would look like. A lot of them have to be customized for each client, but it gives you a feel. It's about a third of a page of a 5-page document. But we go through all the different alarms, and we say, hey, it's instruction to the people in the field, so it's just less phone calls to me, really. But it works pretty well. Scheduling is probably the biggest adventure in the program. One of the things that we find, excuse me, for some reason, the person responsible for managing the site disappears when we come out. And it would be really helpful if they were there. And so we try to get them there because they're the ones there every day. And if we're going to give them advice on what to do, that's the person to talk to. So we want to set up a procedure for how we tell them we're coming and how we ask them to get people there to train. So whether it's a phone call, whether it's an email or whatever, that should be set up in advance and make sure you get the right person that can do it. I mean, a lot of times we find out after well into a program that we've been notifying the wrong person. Okay, well, let's fix that. But getting employees out to be trained when you have a lot of turnover is challenging. I mean, sometimes you got to change the times and dates up, and so advance notice and scheduling becomes pretty important. Okay, so now we're on site. Safety, again, it is addressed to some extent in the RP 900. There's a picture of a person with all their PPE on that we talked about. Again, PPE is the owner's responsibility. It's OSHA. We're not going to go too much into it. I've always thought traffic control is probably the biggest risk out there if you're opening spill buckets and how you do that. I think RP 900 also mentions using your car as a barrier. I think that's common practice now. I know we don't always use our car. It's kind of a judgment call. If you got buckets in front of a driveway, that's probably a good place to use your car. If it's a quiet site off in the corner, excuse me, then you're probably okay with some cones. I mean, at a minimum, you need cones. But something I think that gets missed a lot is, if you're out at gas stations every day, you have the public out there, you have the potential for spills, fires, all sorts of things. I think you really ought to familiarize yourself with the site. You should know where the shutoff switches are. You should know where the breaker panels are. I mean, you're supposed to be training on that anyway. You should be talking to the people, make sure they know what you're doing, make sure that if there's somebody else working out there, that's all coordinated together. And that's also in the 900 document they talk about discussing with the staff. And that, I think, gets left a lot. And it's something that while you wouldn't use at every site, boy, when you need it, you better be ready, right? Okay, so paperwork, big part of the monthly inspection for us in California. Excuse me. And alarm history is probably one of the bigger areas that we have to deal with. And it gets more and more complicated as the new systems are coming out. And so one of the things that you need to make sure of is that you get all the alarms. And we currently use two ways to get an alarm history. One is, and I'm going to focus on the Veeder-Root panel. I know there's other panels, but let's just talk about, in the interest of time, just the Veeder-Root panel. You can get the tape. You scroll through the keypad, you get through all the sensors, and you pull your alarm history, and you get this big long tape, and you review that tape. The other way is we plug a laptop into the RS-232 port, which became available because of the vapor recovery requirements, and download the alarm history, which is much nicer. It's ensures that we don't miss sensors and that we can scan and upload and do all sorts of things with that document that you can't do with a tape. Now, we wouldn't recommend anyone doing that unless they get the tank owner, the local Coupa, and the water board to say it's okay. I know the water board's coming out with some guidance on this soon, but that's my recommendation, at least for now. And I know not every Coupa is on board. I think most are, but that's something that we've been doing. And then you got to print your tank and line tests if you have a single wall site, and yeah, so that's the RP900 really doesn't address this part of it. They say, well, we're gonna get to that in a minute, but it's more of a look at the panel, make sure that there's nothing in alarm, and look for any recurring alarms. So they're not so much looking at, hey, can you find everything that's happened and make sure there's something to go with everything. It's more of a looking for trends. This is what I wanted to do because I know it's in the afternoon and it's really hard to stay awake with someone droning on about tank stuff. So what we're going to do is I'm just going to ask you guys these questions and just show of hands. And what the idea is here, I'm not going to try to solve these or get answers, but just to see, is there consensus or not consensus? Let's just see if everybody gives the same answer or different answers. So the first one is, if you have a DO that gets an alarm history every month, is there any other alarm logging requirement? So does the DO requirement, here's the question, does the DO requirement satisfy all the alarm logging requirements? How many say yes? Okay, how many say no? Okay. Is a handwritten alarm log acceptable? How many say yes? How many say no? What's on the handwritten log? A list of all the alarms. Just a list of just what you would get. So RP900 also, there's an interesting thing I got a kick out of. It said if your alarm panel does not have a printer, then you can have a handwritten record of your passing tank and line test. Okay? How many would accept a handwritten record of a passing tank and line tests? Okay, that's kind of what I would have thought too.
When you're talking about the handwritten log, what do they have to supplement their log? What evidence, what documentation?
Right, now my read of it is there isn't anything else. That's all you get. You come in, there's a piece of paper that says pass test on da-da-da. Personally, I'd have a hard time with that, but all right, so just more on the alarm history, the different types. I think we covered all this. But, it's important to get all the S's, T's, L's. I think it's easy to miss that you've got vacuum alarms out there. They're all part of any leak-related alarm should be included in the alarm history, which can be difficult when you're scrolling through to make sure you get it all. And then you got to cover the entire period of time since the last time you were out. I think that's pretty obvious, but it's surprising what isn't. Okay, so alarm response. So now we've got our alarm history. We've got to make sure that there's a document to go with every alarm. Something that says this alarm. So this is what you have to look through to see if you can find something that says that some alarm sometime in the past month was responded to, which can be a challenge. So if you can't find it, you should try to look for it. But in any case, the regulation says there has to be an appropriate response, right? So the DO is supposed to find an appropriate response. So when I think about that, and let's just say there's a response by a contractor, and the contractor is an ICC certified by the manufacturer. I've got a DO that's taken one test and then the training that I've given them. I'm going to say, yeah, that's an appropriate response. That contractor's been trained. They've got far more knowledge than my inspector does. I'm not going to second guess that contractor. Now, if that contractor, let's say, is doing something that I don't maybe think is probably the right thing to do with my limited knowledge, I might tell my client, I might tell the tank owner, hey, you may want to just check into this, or check with the Coupa, make sure they're okay with it, and what's supposed to be done is being done. But I don't second guess their work. Which isn't one of the questions I asked, but I'm just out of curiosity. How many agree with that the DO shouldn't second guess the contractor's work? How many say, yeah, that's right? How many say the DO should be checking the contractor to make sure they do it right? Okay. Well, that's kind of scary. Okay. So, but, then the other part is tracking. If you can't, oftentimes we can't always, if there's especially sites that go into a lot of alarms, maybe they're having trouble, really need to track what you found and what you didn't find, what you need to deal with before the end of the month. All these things you sort of have to keep track of. And so you have to have some procedure. And how do we talked about notification. You have to have a way to catch yourself up so you don't let these things slip through the cracks. Okay, some more questions. So are these appropriate response documents, now that it's on our head? An email, would you accept an email from the contractor said, I took care of this alarm? How many say yes? How many say no? Okay. How about a repair log entry? So they have a repair log, contractor writes what they did on the repair log. How many say that's okay? How many say repair log no good? Okay. So remote monitoring, so some companies have a company that remotely monitors their alarms, and they might have an operator that enters information, and then you can print a report, and it says this alarm, this response. How many would say that's good documentation? How many say that's not good documentation? Interesting, okay. Sensor out alarm, okay, so not a fuel alarm, not a fuel alarm, a sensor out. Typically they come and go. Is a test required after a sensor out alarm? Okay, or is this all functions normal? So how many say you should have to test that sensor if there's a sensor out alarm? How many say if it's all functions normal, we're good? Okay. This next bullet, I don't know. So is it acceptable to add brine to a reservoir? That's kind of a trick question, right? Right. So maybe we come back to that. We have a big conversation about it at the end. But how many would say, let's change that one. How many would say it's okay for a person who is not certified by the manufacturer to add brine to a reservoir? How many say it has to be a certified person? Okay. And document, yep. Okay, what about communication alarms? If it comes and goes, as long as we say, hey, communication alarm came and went, it's all functions normal now, there's no more action required. That's all good. How many think there should be some other response regarding a contractor for a communication alarm? Yeah, those are tough ones. Okay. Okay, so test documents. Pretty basic stuff here. I don't think there's anything surprising to those of us who have been doing this, but you got 30 days to get them on site. I think some of the keys here are going to be around reviewing the entire document. not just looking at it and putting a date down. You got to make sure every component was tested, if it's a monitor cert or a secondary containment test, which means you got to know what the components are, right? In order to really look at those tests, you have to know what's there. And then making sure they're there every month. It's surprising how these documents move out of their filing location. You can't say it's there this month, so I'm going to keep checking it off every month because I saw it 6 months ago. You got to look at it every month. They walk away, and I don't know why or where they go or who takes them, but they do go. And so every month they got to be looked at. And then, of course, cathodic protection, single wall. That's sometimes, I think, they're kind of lost in the shuffle with all the secondary containment sites out there now. And there's some vapor recovery testing that is out there. You know, it varies almost from site to site. It can vary, so that's just something to be aware of for anyone who's looking at that piece. And then there's other documents. There's past DO reports. Now, 2715 says keeping the past DO reports and the owner statements is the owner's responsibility. That's not part of the DO inspection. So again, back to that scope. Hey, you're going to do that if you're the DO and you have some, integrity. You're going to make sure that that stuff's there. But technically, it's not part of the DO inspection. That's the owner's responsibility. Business plans and monitoring plans. Here's a big scope question. Someone comes up to you and says, hey, can you review the plans for me? Well, I don't know what that means. If I have to review your plans, I might as well write them. If you just want me to see if there's one there, that's fine. But to review an entire plan is a fair amount of work. And so again, what is the scope? RP 900 does kind of touch on that. I thought it was a good section that it says you really should have a diagram of the site and a listing of what's out there, what the equipment is, kind of like the monitoring plan. So there's a little correspondence there, or a correlation rather. And then, rest is basic stuff. MSDS is a lot of times, we're real good at having gasoline and diesel, but not so much the other chemicals that are out there. And so that's something that gets lost too. Okay, more questions. Owner statements. Does a DO owner statement only need to be resubmitted if the primary DO changes? So anything else changes, whether it's a test, ICC update, the alternate list, that doesn't matter. As long as it's the same person, then I don't have to send another one in. How many agree? And then how many say, if you take the test again, meaning you have a new expiration date, you got to send in a new statement? Okay, you reread 2715, it's not in there. But that's what we do, we send them in. Well, we ask, just so I sometimes will talk about what I think or hear or what my interpretation is. Rest assured, inspectors and clients, that we do not manage to my interpretation, we manage to your interpretation, which is fun to try to figure out sometimes. But plans, okay, who says you have to have a separate hazmat page for every grade of gasoline? Who says one page for all grades is good? The inventory, yeah. In the business plan, the inventory in your business plan. So that's a mixed bag. How about, do we want to talk about SIRS? How many will be requiring a printout from SIRS be on site? How many will not require any printout at all? Huh. What's that? What if the power goes out? You probably won't be doing an inspection.
Well, you won't have a business plan recorded if you don't have it on paper.
If I don't have it on paper?
Yeah, then you can't refer to it.
Oh, so you're saying like real world, hey, I need my business plan for my emergency procedures, right? Right, okay, that's a good point, right? So, and I think that's something that sort of got lost in the whole SIRS thing, which is, hey, we want to go electronic, but this is a plan that needs to be used for an emergency. It's got all your emergency procedures. So just my opinion, I don't have these answers, I'm just throwing it out there to confuse everybody, but I think what you ought to have is something that's very simple, like you could almost put in 1 or 2 pages, front and back, laminated thing that says, hey, when you have an emergency, person, grab this thing, it's going to tell you what to do. Don't go into your binder, flip to the section on the business plan, pull that out, they should have something they can just grab and say, hey, here's what I got to do, let's go, let's start turning things off, or whatever they got to do. So I don't know, regulation-wise, power outage, how does that work with not having paper on site, but that's what I think makes the most sense. I just want to know what's going to get a violation. We skipped there. So permits, how many would say if they went to a site and, that's not a very fair question, but if agency's late sending out the permit copies, would you say that would you write them up? Would you say that permit's expired? Yeah, I wouldn't think anyone would do that. Okay, so now we're looking at equipment, spill buckets, right? Got to find out if there's no liquid and debris. That's pretty consistent, I think, with the rule and with RP 900. Drain valves. Carb is going to want to make sure the debris bucket and the pump is there. Got to have fill tag. That's your weights and measures. RP 900 has a bunch of other stuff. They talk about looking for obstructions. How do you test a drain valve? Well, I'll tell you what we would do is you just make sure it's got a chain or a lever on it and that it looks like it's seated. I mean, with vapor recovery systems, the ISD systems, where we try not to open those things up or push the poppet like they used to because you start to change the pressure inside the tank and that messes with that ISD system. But that's all we do. Anyone else? How do you test a drain valve? Other than doing a leak test, right? Yeah. And then the sack around the bucket, I like that one. So if you have a direct bury spill bucket, you should have something in there to collect any fuel that goes around the bucket. I had not seen that before. I learned that one.
Can you speak more to the drop tube inspection in more detail?
What the RP 900 says to do? So I'm going to just, off of memory, they're looking to make sure that it's there, and that it's seated right, and that it's got 6 inches from the bottom of the tank. So that's something that you would do annually, right? For in South Coast anyway, for an annual drop tube inspection. Was there something you were looking for in particular?
Well, I work for a Coupa, and my concern with what I'm understanding about the drop tube inspection is that you have to physically remove it and do this measuring to see that it's 6 inches from the bottom.
Oh, no.
And visually inspect it.
Oh, no.
Leave it in place, it doesn't have to come out.
Correct. No, you don't. No, we would not ever pull it out. Take a tape measure. You can drop it to the bottom, and you can hook the bottom, and then find the end of the drop tube.
That's going to be covered in PEI 1200.
Okay.
Hold that question.
But we don't. And on a monthly inspection like this, we don't pull any equipment out. We don't. None of that. No. That's beyond the expertise of these folks. Okay, more questions. So this is a big one, is how much is too much, right? So if you saw this, would you say that this spill bucket's in violation? How many say this is in violation? How many say, no, that's okay? I would agree, right? It's got liquid in it. How about this? What if the tank owner says, yeah, I know there's liquid in there. I haven't inspected it. I do it every day. I'll go clean it right now. Would they get a violation? How many say yes? How many say, no, I'm going to let them clean it out? Yeah. Right, okay. I was talking about the water, not the cap. How about this one? It's got a little bit of debris at the bottom. How many say, yeah, that's in violation? How many say no? How about this one? A little crud that's kind of wet. How many say crud no good? How many say that's okay? This one's not wet, but it's got a bunch of dirt, it looks like, or dust or something. How many say this is in violation? How many say this one's okay? This one got a little bit of crud, looks like a couple little things in there. It's hard to really tell, but how many would say that's in violation? How many say no? How many think that picture's no good, we shouldn't have used it? What about this one? One leaf. How many say that's a violation? All right, we're getting somewhere. Okay, UDCs, definitely part of RP 900 to look at the UDCs. They say clean and dry. I think the regulation says no liquid and debris. Kind of the same, I guess. Sensor should be at the low point. If there's some of these dispenser pans have a little trough, so it should be in the trough, or if they have a little dimple in the middle, it should be in there. The Bravo boxes have to have the tight chain, right? You all know that. Shear valve always interested me that wasn't part of the DO inspection. They're in there anyway, but they do have to be tested once a year. Fire code says they have to be tested. And then RP 900 has a bunch of other stuff about cracks and holes and penetration fittings and looking at the piping and things that we don't do, and I don't know that our inspectors are really qualified to do. But I'll talk about this now, but it's kind of interesting the way it's set up. If you read that document, the RP 900 document, the monthly inspection portion doesn't have, we talked about all that emphasis on paper, and it doesn't have all that emphasis on paper quite as much. And got to remember, it's a federal document. It doesn't have all the requirements we have in California. But it does have most of the equipment stuff, and so there's some additional things. Now these are annual. This says annual, right? So RP 900 says once a year you do these, so you don't have to look at it every month. But what's interesting is they say at the start of the annual inspection, you should do a monthly inspection. And this is where I think there's kind of a difference, because the guy that does or the girl that does the annual inspection, I think is a different person than the person in California that does a monthly inspection. Because you've got to be able to really work with the equipment, right? You're testing equipment. You're taking things out and putting them back. And there's a lot more involved. And that person probably isn't the right person to be pouring through all of the documents. It's probably a different type of person. So I got to hurry up. Okay, more questions. We'll be quick. So I don't know if you can see a little bit of liquid pooled in the corner. How many say that's a violation? How many say no? Yeah, that's what I thought too. Okay, how about this? Crud at the bottom. How many say that's a violation? How many say no? A lot of you aren't voting. Cobwebs. How many say that's a violation? Cobwebs. Those are cobwebs. No. Anyone say that? No. That's okay, right?
Well, I can tell you that if it's stuck to the door, then we can tell you haven't been looking.
That's right. Do you ever hear that? If it's stuck to the door, that means you haven't opened the dispenser panel, so you haven't been looking. Sumps. I'm going to start moving quickly here. You inspect when there's not a record of a response to an alarm. Okay, so in the past month. Basically the same type of inspection as before, except you really got to make sure you understand whether or not it's a dry or secondary on the lines, right? Because if it's a dry secondary on the lines, then you got to make sure the boots are pulled back. Some people have us look at the lids, make sure all the bolts are there. Interesting, RP 900 asks you, is there a lid? That's one of the questions, right? Does it actually have a lid? I mean, there's questions in there that you don't think about here because you take it for granted. It's a federal document. All right, sump inspection required for a cold start. How many say yes? If you have a vacuum alarm, on your sump, interstitial, do you have to inspect the sump? How many say yes? How many say no? Okay, now nobody's voting. You guys aren't that much fun. All right, so emergency equipment. some of this is covered sort of in RP 900 because they say you have to have the materials to clean a spill, which kind of corresponds to the DO inspection, right? In a way, because you got to train on that. But these are all things that, if maybe they're not getting done every month, but they should be done by somebody. They are requirements in the state of California. Someone should be inspecting them at some point to make sure that it's being done, whether it's the DO or somebody else. Decals and signage, this is not your stuff mostly. I know some of you look at NFPA. None of this is really part of the RP 900, but they are requirements here that we have to deal with, and they are part of the dispenser. So these are some of the other things that we don't typically deal with that are in the RP 900 document. And again, it's kind of those things that we sort of take for granted and we don't deal with. Hey, check number 1 is the canopy on fire. Check number 2, hazardous waste is sort of alluded to in that there has to be some spill cleanup procedures. And if you're going to clean up a spill, you have to have a place to put it. So if you have a place to put it, you have to know how to label it, and on and on. So where does that stop? We happen to be a hazardous waste transporter, so we spend a lot of time looking at their drums and their labels and are they stored right? And I know you all do too. So somebody, again, needs to train these people on how to do it, whether it's the DO or somebody else. But the DO requirement just says, hey, how do you clean up a spill? So where does that end? To me, it ends at the drum. Hey, you put it in the drum, make sure there's a label on it, date it. That's kind of where it ends. It can go on from there, obviously. In the interest of time, I'm just going to keep moving. So these, I'm going to flip through these. These are just more of the same. How much is too much? This is a good one. How many thinks this is too much rust? You'd write them up. See, I thought that was too much because I don't know if that lid's going to seal. How about that one? Is that too much rust? How many say yes? How many think that's okay? Okay. How about that one? Okay. All right. So labeling, the point here is there's a lot of conditionally exempt generators out there. They should have a second date when they get to 220 pounds total accumulation. That means they haven't accumulated 220 pounds in a calendar month. That's based on this table. California says you can accumulate, if you accumulate less than 220 pounds in a calendar month and your container's in good condition and you haven't gotten to that quantity, you really don't have a time limit to remove it. You can be there indefinitely as long as it satisfies all the other storage requirements. TSDF manifests are a big deal, I know. We're always looking for those TSDF signed copies. I think that's pretty basic. Now here's one slide to cover 4 hours of vapor recovery training. Next, RP 900 does cover it a little bit. They talk about daily inspections. Again, not part of what you guys do, but it is in there. Okay, so employee training. There, again, they talk about spill response. You'd have to train the employees on spill response. I think there's a little bit more to the DO training that's supposed to take place. And then follow-up, it's important to make sure you document the results properly. There's a state form out there for the DO, but I don't think it's required, actually. I think probably most people expect to see it, but I have not seen anything in the regulation that says you have to use this form. I think most people use it, and that's the expectation, but it's not in there. You should document if you're doing these other inspections, that it should be, these other items, it should be documented somehow. Again, you got to track those things. You can't, no good looking for things unless you track them and communicate them. And then fixing things. I mean, a lot of people think the DO can fix a lot of stuff that they see, and there's a lot of things they can't. I mean, you're not allowed to repair hanging hardware. Obviously, you can't touch the panel programming. Add brine, we figured that out, right? And some of the things you can do, you can move a sensor. If it's tipped over, you can pick it back up. You can put it back in its sleeve. You can remove debris or liquids. There's nothing wrong with that. retrieve documents, label drums, all those things are fine. This is pretty important in terms of discussing the findings. Again, I think that a lot of folks out there are doing these inspections, sticking in a binder and walking away. It does say, yeah.
I don't think it's advisable for a non-certified person to move a sensor because the sensors have tags on them from the last person who certified that the sensor was at the lowest point. So if you are not a certified technician and you move that sensor, you're basically violating that tag that was left by the person who certified it at the lowest point.
Okay, so be glad to hear from the group, but my opinion on that is that person certified that that sensor was operational in the right position at the time they tested it. This is a later date, and if it's fallen over on its side, I have not seen, and I'm glad to hear from you all, where it says that I can't pick it up and put it in the right place, that it has to be a technician doing that.
Well, I guess my response would be, I think it's fairly clear that the DO is allowed to remove water if there's water in the UDC or there's water in a sump. And if in removing that water, there's a potential that the sensor is going to get knocked over, and the DO is going to be able to put that sensor back and not have to call out a certified technician to relocate the sensor after they remove water. And so I'd call it a similar situation. I think they could reposition the sensor.
So that sounds like a good show of hands. Raise your hand if you would be okay with the DO picking up the sensor to straighten it out if it had fallen down. All right, survey speaks. Did we have one more question?
I noticed a lot of the contractors now are taking photographs of the monitoring equipment when they test it and then put it back in the position. They're photographing that. That's part of the record. So if there's any question about where that sensor was placed, they have it as a photograph. I think it's a good idea.
So I don't know if everyone caught that, but it's good to have pictures, then you can say, yeah, here's where it was when we did our test, yeah.
So I think the conundrum, too, is that the DO is responsible to, it says in 2715, they have to say that it's in the lowest place, but where does it say a new tank system like a VPH? We've recently looked all over the regs for this. Where does it say that sensor has to be at the lowest place where the liability is on the operator, owner-operator, or the technician, the licensed technician? It doesn't specifically say that. You can take it back to construction where it says detect a liquid at the earliest opportunity, but there's no language in there for new, super new, I call super new tank systems, for a sensor to be at the lowest point, except for the DO to look for it.
Okay, so, I mean, again, that's lots of fun stuff we get to deal with every day, but in terms of this piece, the follow-up is important, especially if you have a multiple site, 150, whatever number of stations. You need to track whatever it is that needs to be fixed, because there's nothing worse than finding things and not fixing them, right? That's it, I'm done.
Again, I'm Brian Harmon, Tate Environmental. I was on the committee for the recommended practices for the testing and verification of spill, overfill, leak detection, secondary containment equipment at UST facilities. And I have to read it because I don't have the name of the manual memorized yet. We just call it RP 1200. Oh, can everybody hear me okay? So, there we go. I just want to thank everybody or the Coupa 4 board for allowing me to be here, and the committee members, and everybody that's here today. Being on the committee was interesting because, as you can tell by just the name of the manual, there was a lot of voting going on. And it was definitely an interesting experience. We've been asked, or PEI had been asked to put the manual together as an industry service. Basically, everybody wanted the. I shouldn't say everybody. There was a lot of requests to try to get what we do out here in California not necessarily as a standard, but try to get everybody else on the same page for checking the equipment the same way. When I got out here into California, I knew that how we did things out here, and I just thought that was the way that it was done everywhere else. But by being on the committee with the other contractors, there's different ways that everybody else was looking at how to get things done. And what we were trying to do with this document was to get all the procedures, or try to set a standard for how things should be checked out, or how and inspected throughout the country. Again, we tried to get not necessarily one document for everything, because then the manual would be several hundred pages long. But we did look at information from all the manufacturers. We tried to get other regulatory people, or regulatory agencies and other practices, and tried to get that all into one general document. The committee had equipment suppliers, tank owners, testing companies, and industry associations. So again, trying to get everybody's input on it. And we started out with a conference call. We had three meetings and then various conference calls in between, and trying to get everything tailored down. And in addition to what we did on the committee, we put the document out for public comment. During that public comment, we got 251 responses back. And it was from regulatory agencies, from manufacturers, from other testing companies. And we had another meeting where we sat down and actually went through all of the comments and took all the comments into consideration, and some were adopted and some were not. And as of right now, if you go to PEI's webpage, you look under the RP 1200, and then you'll see a spot for commenting now. And the reason why they do that is so that if they start getting a lot of comments about one topic, then they may recall the committee and readdress those issues that are brought up. If somebody says, well, we don't like it, they're probably not going to do anything about it. But if there's one topic that comes up, excuse me, with a lot of comments, then they'll go ahead and call the committee back. But we really won't readdress this. The standard period is 5 years. There were times where, some of the procedures that we were discussing, may not have followed each individual manufacturer's, procedures on how to do it. So a lot of times we went ahead and just try to summarize various manufacturers' procedures and, keep things in a general nature. The whole idea being is to verify that the release detection equipment is operating, that the overfill protection equipment is installed properly and operational, the secondary containment equipment is tight. But there were times where some documentation was not included. Excuse me. As we know now, spill, overfill, leak detection equipment, and secondary containment equipment is required by all the regulations. And in order to operate effectively, it has to be inspected or tested to verify that it's still operational and still able to do what it's intended. And again, what we're trying to do is provide a a summary of procedures or a summary of general guidelines for inspecting and testing of the, the various equipment, including the shear valves and emergency stops. What we were trying to do is, again, make sure that the equipment itself is able to protect human health and the environment. Basically, we want to make sure that the equipment is doing what it's designed to do, and that it's installed the way it's supposed to be installed in order to do what it's designed to do. We do not intend the document to endorse or recommend particular materials or equipment. We don't want to discourage development of new technologies. As new technologies come up, we can incorporate them into the document. And we don't want to discourage the development of testing procedures for the new equipment. If you have any questions, by all means, just let me know. Okay, so the recommended practices applies to underground storage tanks, connected underground piping, the ancillary equipment, and the secondary containment systems. It's not, we don't expect it to apply to underground or above ground storage tanks, mobile tanks, dispensing equipment, meaning from above the shear valve, and then tanks containing refrigerated liquids. That's going to be a whole different document. The test methods that we have in the document are based upon industry practices. It's intended to demonstrate that the leak will be detected before it reaches the environment. And then, of course, if the authority having jurisdiction has a more specific leak detection protocol or procedure, then that takes effect over the document. RB 1200 is not meant to provide an interpretation of regulatory or legislative requirements related to UST systems. Okay, on the definitions section, we do have a lot of definitions in there, but these were two definitions that I just wanted to put out or point out because, here in California, we look at a double wall tank and we automatically think that it's what they call a tight wrap tank, where there's a small annular space. But I know for a fact that we do have tanks with oversized annulars. They're your older tanks, usually your first or second generation double wall tank. The reason that I have it in there is because there are different ways or different procedures from the manufacturers and associations for testing what they call 110% containment tank, which we'll get into in a little bit. But again, one of the common factors that we had out here doing all the secondary containment testing that we do is I've seen a lot of tanks with oversized annulars where technicians will come up and test them just like they would a tight wrap tank. And that, they have to be identified, and again, per the manufacturers and the associations, that should be, they should be handled a little differently. Any questions? I'll keep asking, make sure you're awake. On the safety chapter, we put that in there because everybody that does this work should have some kind of safety training. Because again, the technicians out there, you've got an active gas station, or even if it's closed down, you still have foot or vehicle traffic. So we wanted to point out in the RP that, we have a definition there for a competent technician. And that competent technician also includes proper safety training. Okay, tank secondary containment testing. Again, for the tank secondary containment, There are two types of tank secondaries. There's a dry vacuum test and a wet or hydrostatic test. The dry test method, the test procedures that we have in the RP is general in nature, where vacuum is pulled down for a period of time. The test duration depends upon the size of the tank, and the amount of the vacuum depends upon the type of the tank. One of the things that we point out in the RP is the first thing you need to do is identify whether it's a tight wrap tank or 110% containment tank. If it's a tight wrap tank, you can use RP 1200 test procedures. If it's a 110% containment tank, you follow the Steel Tank Institute's R012 recommended practices for testing of interstitial tightness testing for existing underground double wall steel tanks. Okay, I'm moving on. Dry test method. For fiberglass tanks, you can use the RP 1200 test procedure, or you can use the Fiberglass Tank and Pipe Institute field test protocol, for testing, double and triple wall tanks. Again, this is for dry annular testing. On the dry test method, for a tight wrap tank, be it newer generation double wall steel or steel clad, or a double wall fiberglass, you pull it down to 10 inches of vacuum. Depending upon the capacity, determines whether you have to hold for 1 or 2 hours. For a 110% containment tank, you pull it down to 6 inches of vacuum. And again, depending upon the volume of the tank, determines whether it has to hold for 1 or 2 hours. And that's where the difference that, I know that out here, like I said, I've seen a lot of technicians just pull up and start testing any tank at 10 inches.
Brian, why did they decide to go with 6 inches as opposed to the 10 inches that we've all previously been working with?
I'm sorry, what?
Why did they decide on 6 inches for the steel tanks?
Oh, that's from R012 from Steel Tank Institute. The reason being is when you have an oversized annular, the more vacuum you put in there, the outer tank is already getting compression from the backfill. And then you're putting more of a vacuum on the primary, so you're causing the steel to flex even more. And their recommended practice is, if you're going to do the test, only pull it down to 6 inches. And that way you're limiting the stress of the flex on the steel ends. Again, with the test results, if you don't have any loss in vacuum and you don't have any fluid ingress, test passes. If there's any loss in vacuum and there is fluid ingress, we call that a test fail. We recommend a retest once you evacuate the liquid, unless it's fuel. If it's fuel, there may be an indication of another problem. Hydrostatic testing on a wet annular. We mention these in here because these two, the two fiberglass manufacturers, Containment Solutions and Xerxes, have test procedures that are listed as a tank test on the National Workgroup and an LG 113. So we wanted to mention them in there that it is another test that is available to be utilized. We didn't go into the details because both of them have procedures that are a little different, and we didn't want to not include one or only include one and not include the other. So we decided that it's best to just make a reference that they're out there. And if you want some more information, you can go to LG 113, you can go to the manufacturer. But those are procedures that are listed as a tank test. Okay, piping secondary containment testing. Again, this only tests the outer wall of the double wall pipe. Our test procedures are general in nature. All of the piping manufacturers are pretty much 5 psi for an hour. It's just The only difference is how do you secure the secondary space. You know, I have pictures of both the a flex and a double wall fiberglass, and how you get that seal is the only difference between them. And again, it's if there's no pressure change in an hour, test passes. If there's any pressure change, the test fails. And we do have a note in there that if you do the test and after you're done doing it, or if you detect product coming out of the secondary before you do the test, we highly recommend that you do a primary product line test before even testing the secondary, just to ensure that the liquid that's in the secondary, it might have been from like a filter change that occurred in the UDC, and then product got down into the secondary, that you don't have a problem with the primary. Because what's going to happen is when you put the pressure on there, you may make things worse.
Well, it's not as critical on the fiberglass pipe, but on the flex line, when you're doing the 5 psi pressure test, you need to go to the end and you need to verify communication, because I've seen some of them where you'll get 5 psi at the test boot and it doesn't communicate to the other end.
Oh, okay. I can agree with that statement. But that's not in the procedure, but it's something that you can put in as a comment, and we can get that addressed. What we did in the document is we kind of lumped in sump testing and spill bucket testing together, because outside of California, nobody's heard of accelerated sump testing. Everything that they're doing outside of here is all basically lake testing. And that was kind of a shock, because I was ready to start putting in all the comments about accelerated testing, but I got outvoted. Again, the hydrostatic or the spill bucket testing is the same. Or I'm sorry, for double wall spill buckets, you can do a hydrostatic test, a vacuum test, or test the interstitial. We have all three of those procedures in there, for a double wall spill bucket. For our single wall spill bucket, basically we have the same procedures where you clean out the bucket, you make sure the drain valve's okay, make sure the cap's on, you fill it up to 1.5 inches from the top, and you measure the water depth to the nearest 1/16 of an inch. Typically, they've been leaving the measuring device actually in the spill bucket, so that way you can monitor, watch the level. You watch it for an hour. If the drop is less than 1/8 of an inch, it passes. If it's more than 1/8 of an inch, it fails. And the reason why we did that, or came up with that, is because if you're going to measure a drop on a ruler, you're not going to see a 1/16 of an inch drop.
On the last slide, when you put the tape measure down to the bottom of the spill bucket,
yeah,
sometimes the bottom of the spill bucket isn't quite flat. So how do you ensure that there's a consistent reading?
Well, what they do, or what has been done, is you can use a crossbar and have the device, or your measuring your measuring stick, or whatever your ruler, whatever you're using, have that attached to the bar so that sits across. So that way you're not going all the way down from the bottom up. All you're looking for is a level change. If you want to know what the initial depth is, then you're going to measure down to the bottom. But when you're doing the test, you just worry about what's on top. Oh, another question.
I've had technicians say they want to use fuel instead of water. Is that an issue?
We don't recommend using fuel in the spill buckets, just because now you have fuel sitting out in the open, and if somebody comes, driving by and their car is backfiring, it can create issues. It's more of a safety concern. And then the other concern I would say is if you have a direct bury bucket, I would not put fuel in there as a test liquid. You know, we don't recommend it. We recommend using water.
When you're talking about containment sumps, are you talking about secondary containment sumps in general? Because the standard, what we've been using as the industry standard in California is a 24-hour test or the accelerated equivalent.
Correct.
So there's a significant difference between this and the other one, which is a 1/4 inch, I believe, over 24 hours.
Correct. And I got outvoted.
Yes, Brian was outvoted, but
And so was Jim,
here's
by
the
the
water
way.
board. They are going to be working on LG 160, and they're hoping to address some of these things with possibly having local equivalencies that would meet the same standard and possibly things that we're already doing. And Corey's nodding at me yes, so I'm thinking that that's what's going to happen.
And like I said, you can always go to PEI's webpage, look up recommended practices, find RP 1200, make a comment. And I'm telling you, if Bob gets 500 comments on not having, you know, any level drop, then it's something that's going to be addressed.
That's on PEI.org. Just look for
I'm going to go
RP
back to
1200.
that.
Just remember, I know he kind of went through it fast, but anything you don't like in RP 1200, make a comment, and you know they can. And if they get enough comments from us, then they can look into adjusting it. And Bob's not nodding at me. Yes, he's nodding at me. Yes, he is. Bob Brinkus from Petroleum Equipment Institute.
Yeah, like I said, I mean, normally it's every 5 years. Am I correct, Bob? You know, so every 5 years they readdress the, you know, the any of the RPs, and that, I mean, any of them. At the outside. At the outside. But if, like I said, if they get 300 comments on one issue on one RP, then they're going to reevaluate. Well, maybe we better get the committee together and, you know, address that issue.
Well, I'm just concerned, has the State Water Board bought into that this is the new acceptable standard for California?
I can't answer that.
Water Board?
We will be attempting to revise LG 130, and that'll be the guidance that will be based off of LG 160, sorry, and that'll be based off of PEI 1200. But it's business as usual right now.
Yeah, so no changes for right now because of this. It's an introduction and a work in progress still. We have one more question.
Oh, I'm sorry.
So it looked like on the spill bucket test, you were just addressing a one-size spill bucket, and if there's a larger spill bucket, like 15 gallons, does it matter that it needs to be, you're recommending it to be filled to the top?
Yes, the procedure does not, is not capacity specific. The procedure is to fill it up to 1.5 inches above the, or to the top of the bucket.
Without regard to the 5-gallon requirement?
Correct. The reason being is if there's a problem with the top part of the bucket with the cap, you know, you're not going to know that if you only fill it up to, you know, 6 inches or 4 inches below the cap to meet your 5-gallon capacity.
Right, but during operation, the cap's not in place. And that's always been sort of the field argument that I've run into.
Yes, it has. I agree that it is an argument, but the idea is to test the entire spill bucket. Not just, there's nothing in there about, you know, just testing the 5-gallon portion of the spill bucket.
Any other questions?
So when we're testing a spill bucket, are we testing the cap?
Yes. Well, we do have an alternate in there. Wait, let me get back to it.
I mean, I don't understand why we're testing a cap if it's going into the tank. I mean, if we're looking for a leak, that cap.
Well, we're testing the cap and the drain valve. See how the fill cap is underneath? The fill cap's on the riser on the picture.
But that's not the spill bucket.
On the spill bucket, yes.
No, the cap isn't the spill bucket. You say the cap's part of the spill bucket?
The fill cap is part of the spill bucket. I must be misunderstanding what you're saying.
No, I'm saying that I can't see how the cap is part of the spill bucket.
Yeah, the cap is an integral part of the spill bucket because that's what helps contain any liquid. You know, the thing is you're putting a vessel in the ground. I mean, you're putting the spill buckets in the ground, liquid's going to get in it. You know, the cap is part, just like the drain valve is part of the spill bucket.
So if the recommendation is to test with the cap in place,
yes,
should there be a prohibition on the tester from replacing the existing cap with a tight-fitting cap for the purposes just of testing?
Well, one of our pre-test procedures is to check out the gasket on the cap and make sure that you do have a tight seal. Also checking out the drain valve and making sure it's cleaned out and that you have a good seal on the drain valve. And if either of those components are found, bad, we recommend that they be replaced before the test.
One more.
Sorry, I just wanted to make a clarification. We're testing the spill bucket.
Yes.
If the cap is bad, we're not going to fail it. You can tell if the cap's leaking by when they drain it down below it. You can look at the drop tube and see the water droplets inside. So that's one way to know. Plus, you'll see a swirling on the top of the layer of the water, like a Coriolis effect. So you know that it's leaking somewhere. Usually, the only three things is the cap, the drain valve, or the swivel adapter's loose. And you can eliminate those three things, and we do allow them to use a new cap because we're not testing the cap. We're testing the outside of the bucket.
I understand what you're saying, but there have been instances where water mains have broken, and the water main breaks, goes over, a gas tank or gas station tank, whatever. One of the caps has a hole in it because it was not installed properly. So 4,000 gallons of water goes into the tank. Where does the fuel go? That's why we included the cap and the drain valve as part of the bucket. Now, we do have an alternate in there where the authority having jurisdiction may allow removing the cap, putting the plug in. Okay, that's the next slide, sorry.
Last question.
Oh.
That cap is inside of the bucket, that's why it's there. Okay.
Okay, but, so we are employed to find out if they're in compliance, and then we're supposed to be if they're in operational compliance with prevention and detection. So if the cap fails, they're out of compliance.
Correct. Well, they have a failed spill bucket test.
Right, they have a spill bucket test, they're out of compliance, and so we need to notify the EPA eventually how that gets to the EPA, right? That they're out of compliance with whatever one we decide they're out of compliance with. So I think you fail the spill bucket, they're out of compliance. Not that they can't correct it, it's not a violation, but for the compliance issue that we report to the state, then they report to the EPA, they should be out of compliance for that.
But again, the pre-test procedures that we have are for checking out the gaskets, checking out the drain valve. If we see any obvious problems before we do the test, we recommend that repairs be made before you even do the test. Once when you do the test, if everything looks good, you have a good seal and everything, but you still have like a drain valve isn't tightened up enough or whatever, then you're still going to get some leakage, through there, and you still may end up failing the test. But the whole idea is to make sure that equipment is there, and that it is tight. So it's, just want to point out also that the Fed EPA has guidelines for tanks that are in potential floodplains, and one of their procedure or one of their recommendations is that the fill caps and drain valves be liquid tight. And again, on this one, we say again that the authority having jurisdiction, is allowed to, or if they tell you to go ahead and plug it off and do the test, just make sure the spill bucket is tight, then you can do that. We're not trying to supersede their, the local jurisdiction. On the vacuum testing, again, the pre-test procedures are the same. Clean it out, make sure everything looks good, looks tight. Put the vacuum on the spill bucket. pull it down to 20 or 30 inches, you wait a minute. After a minute, if you're 26 inches or greater, you pass. If it's under 26 inches, it fails. And again, you know, with this test, you don't generate any water. On the double wall spill buckets, again, you can do a hydrostatic, you can do a vacuum test, or you can test the interstitial. There may be a little bit of difference, you know, on the setup procedures, but the manufacturers that we looked at that had equipment out at the time, you pull it down to 15 inches, you wait a minute. If it's 12 inches or more, it passes. Under 12 inches, it fails. And then on the single wall containment sumps, again, you do the same. You clean out the sumps. You fill the water to 4 inches above the highest sump penetration or sidewall seam, and then you measure to your nearest 1/16 of an inch. You wait an hour. If you have 1/8 of an inch or less drop, you pass. If you have an 1/8 of an inch or more than an 1/8 of an inch, you fail. No questions? I thought I was going to get beat up again. UST overfill equipment verification, inspection, and testing. Again, what I wanted to show with this slide is looking at 40 CFR 280. There are overfill options for shutoff, restricting flow, or alerting the operator. For shutting off, you have a 95% capacity or before the top of the tank is wet. Restricting flow at 90% or 30 minutes prior to overfilling. And then alerting the operator at 90% or 1 minute prior to overfilling. There's 30 minutes and the 1 minute. On the restrict flow, 30 minutes prior to overfilling and alert the operator, they have to happen at the same time. That's the combination, but everything else can be standalone.
So I think this is where the timing of my question when the prior speaker was speaking falls into place. Can you speak to the details of what the verification or inspection entails with respect to verifying the 95% tank capacity shutoff?
That'll be coming up. If you'll bear with me for about a couple more minutes.
You're still early.
But you're better.
It's like a couple more slides.
Okay, again, these are the 3 overfill devices that are primarily in use, you know, for your shut-off, restriction, or alerting the operator. Here we go. We decided to go ahead and develop protocols that were reflective of the most conservative application of the rules. Basically what that means is, you know, there are various combinations with all the equipment out there. We didn't want to try to come up with inspection and testing protocol for all the options that were out there. So we just picked the shut off at 90%, shut off at 95%, restrict at 90, and alert at 90. The one thing I wanted to note here is, again, out here in California, we deal with, you know, carb EVR on the gasoline tanks. And anytime you disconnect a threaded fitting, you know, to do any of the following inspections, you know, there's going to be some kind of testing, and that'll have to be completed after the equipment is reinstalled per the executive order requirements. Okay, here we go. To inspect the flapper valve, for lack of a better word, you do have to remove the flapper valve from the tank. Depending upon the configuration, determines what has to be done to remove the flapper valve. But that's the only way that we're going to know, at least with what's installed out there now. I just saw that OPW thing, it looks pretty cool. But what we have right now is to make sure that that float is there, because I can't tell you how many times I've taken drop tubes out of tanks, or my guys have taken drop tubes out of tanks, and the float's missing. So you look down there, everything looks fine, you know, but when you pull it out, it's gone. You know, or it's half of it's gone. You know, so, you know, we fought about it a lot, but, you know, you have to remove it from the tank. And when you remove it from the tank, you have to be able to make sure that when the float is engaged, or the float's all the way up and engaged, that you can see the valve release, you know, through the drop tube. It's real easy to do when you have a short section like we had in one of the earlier meetings. But, you know, whenever you open up or whenever you trip the flapper valve, you'll see the actual shutoff device come into the flow path of the fuel. And then that's how you know that that works.
So we test everything in water, and we're saying we don't have to test the drop tube in water? I mean, right, we don't know if how it works. If we lift it and make it work, it works, right? So now you're saying that that's okay to lift it and make it work, but if it's in fuel, does it work? This is the question.
Now I'm starting to feel picked on.
But then the microbes will grow and rust and eat the tank.
No, I mean, you do make a good point, but the only way we're going to verify that is to overfill a tank. And I don't think we want to be doing that. So we immediately discounted that option as a test procedure. You know, in talking with the manufacturers, if that valve gets into the flow, the flow of the fuel going into the tank, that it will seal. So all we have to make sure is that the float will release the valve.
Does that mean that now the technician also needs to have a vapor recovery certification when he's taking the drop tube out?
It's my understanding that CARB and the Water Board are discussing the matter, but as of this point, yes. That is a true statement. They should be an ICC, VT, or VI. They should be manufacturer certified for the phase 1 equipment that they're taking out. They should have the torque wrenches for ensuring that it's installed at the proper torque when they reinstall it.
Is this only for petroleum?
I'm sorry?
Is this only for petroleum tanks?
Only for gas tanks.
Diesel?
Diesel's not governed by CARB, so we don't have to do any testing afterwards.
And
oh, the test is done on every, yeah, I'm sorry. I thought you were talking about the CARB certification. Yes, this is for any tank that has to meet the overfill requirements.
Yeah, so that could be a hazardous substance tank that has to meet overfill requirements federally? Annual, every year?
Now, just as a side note, we have some ammonia tanks that we do the certifications on annually, and we note down that we're not pulling the annular, or we check the annular sensor, but we're not pulling the overfill, you know, the overfill pro or overfill sensor. We're not pulling the drop tube, you know, just because of what's in the tank. So there are considerations that are made, or that have to be made, you know, for the safety of, you know, the technician doing the work. This is a picture just showing one of the potential installations you're going to see of a ball float at a gas station tank. Because of the phase 1 EVR program, a lot of older tanks had to be upgraded to the newer phase 1 equipment. When the Mamways came out, they were 16-inch center to center. A lot of the older tanks had bungs that were 14-inch center to center. So we came up with creative ways of getting the vapor bucket over a couple inches in order to be able to fit into the the Mamway. So again, that's a threaded fitting. Once you take that out, you'd have to test it. Again, on the electronic alarms, you remove the probe from the tank, you visually inspect it, make sure the floats are good, and then you measure the length to Measure the length to ensure that the alarms occur when the tank is at 90%. Electronic system inspection and testing. Again, when you're coming up to the console, you look at the console, make sure there are no alarms. You check the program, the programming of the tank, make sure it's programmed to meet the local and state requirements. Again, this is general in nature. You verify that the setup is okay, verify that all the lights are working, verify that the LCD is operating. Again, when it comes to the probes, you're going to, seeing as how you already have them out for the one inspection, you can basically do the two at the same time. The one thing I wanted to note is that some tank probes have point spots where, just move the float or set the float to a point and it'll trigger the overfill alarm. Others, you actually have to simulate a delivery by moving the float up and having it trigger, moving it up and past the alarm point to where or up to the alarm point where it'll trigger the alarm.
On the last slide, you indicate verify that the floats are indicating the correct liquid level. How?
You go ahead and you stick the level in the tank, before you even pull the probe. The console will be giving you a fuel level in inches. You stick it in the fill. You see if it's within an inch, inch and a half. You can check the tank tilt. There's other ways to verify it, but that's how you're looking to see if it's close.
So you guys are recommending procedure for how they verify the accuracy of those floats?
There's multiple ways to do it, and we didn't feel that we needed to put down a step-by-step. We just verify what the probe is saying versus what's in the tank.
The ball floats, don't they need to know tank manufacturer and the size of that tank and get the charts from the manufacturer to indicate 90% or?
Okay, for ball floats, if the tank top is direct buried and you can't access the extractor fitting, what do you do? And then for automatic tank gauging systems, is this only an issue if it's a single wall tank or if it uses the ATG system for overfill? Do we need to care if it's a double wall system?
Well, what we're recommending is that this inspection be completed if ball floats are the primary overfill device. Okay, this is for your primary overfill inspection. I know that there are ball floats that are installed in other combinations, and if they're installed and the authority having jurisdiction wants to inspect them, these are the inspection or the procedures that we have for it. But if it's the primary, then it should be inspected.
No, I'm saying, what if it's not accessible?
Then it's between the tank owner and the AHJ to either make it accessible or find an alternate. That's where it comes down to. We're not trying to say this is what you have to do. We're just saying that if you're going to do it, this is how you do it. We're not trying to say that everybody has to dig up all their tanks and put sumps everywhere. That's not what our intent is. Okay, interstitial sensors. Again, you're going to make sure that the sensors are installed properly. We recommend that the sensors be dipped. Again, we had debates about discriminating sensors, that they should be tested in the liquid that's being stored in the tank, and you can read the RP and find out who won that vote. Again, we're going to, when you're doing your inspection, you want to make sure that the interstitial sensors are in the right position. You're going to submerge it. If you require to have shutdown, you make sure that the turbine shuts down, and then you verify that the sensor is properly labeled in the ATG console setup. Automatic line leak detectors. There are two types. There's a mechanical and electronic. The test procedures that we used say that the automatic line leak detector should be capable of detecting a 3 GPH leak at 10 PSI. We say that the test apparatus must have an adjustable orifice. And we say that the calibration of the adjustable orifice should be accomplished or can be accomplished with or without a pressure regulator. And we do describe both of those procedures in the ERP just to show it, just to give you the option. One of the things that the test will confirm is that the STP will turn on and off. Again, that's verification that the tank or the turbine relays are operational. We simulate a leak at the dispenser that is at the highest elevation, but you also want to try to get both the highest and the farthest. So if there's a satellite dispenser that is further away than the primary dispenser, we recommend that you test at the satellite dispenser. All right. One of the things we do is a visual inspection. As you can see, this one was a colorful inspection. We also want to make sure that while we're doing the test, when we bleed it down, we see it trip. Then we verify that the leak detector sees a simulated leak at 3 GPH and that the slow flow condition exists. And we recommend at least 1 minute of slow flow time to ensure that the leak detector is seeing a leak and not being fooled for other reasons. Electronic leak detectors, again, you're going to do a visual inspection. Basically, you want to simulate your leak the same way. You're going to make sure that the console searches for the leak. It may cycle the turbine on and off a couple of times. And then you also, if positive shutdown's required, you make sure that that's in there when we do the test. For shear valve inspections, there's really no testing because we're not going to drive a car into the dispenser to make sure that it works. Beat you. But you do want to make sure that the shear point is mounted properly and that the product shear valve is anchored. And you also want to make sure that the shear point on the vapor shear valve is anchored and that the shear point is at the right spot. Again, you're going to do a visual inspection. This one failed the first time, so they fixed it.
Remember, it's only recommended practices.
You just basically make sure that the valve will seat. You seat the valve, you try to pump gas, you shouldn't get any gas. With the vapor shear valves, again, you're just making sure the shear point location and you're making sure that it's mounted securely. Emergency stop switches. This one, actually, you need to have the key to get to it. But again, you want to make sure that, every emergency stop switch at the facility is tested. And you have to do those individually. You can't do them continuously. So basically, you'd have to, test one, bring it back up, test the next one, bring it back up. And that way you do it for each one. You also have to make sure that they're labeled and accessible. What we want to make sure is that the emergency switch will shut off power to the dispensers. It shuts it off to the STPs. And then it also shuts power off to any other control signals that are associated with the dispensers or the STPs, and then any other non-intrinsically safe equipment in the classified area. I just wanted to point this out because when you have a separate electronic line leak detector system that is working in conjunction with your monitoring panel for the rest of the ATG system, it's quite possible that you shut power off to the VITA route, and the CPT will turn the turbines back on to conduct a test. So you got to make sure that all power is disconnected. We do have sample forms in the back of the document for all the testing that we have in there. We try to ensure that you keep proper documentation at the facility. And we do have the logs for the two hydrostatic annular tests in the back as well. We have charts that will convert pressures. We also have charts for converting and measuring vacuum. And then these are just a list of some of the documents, some of the test documents that we have in the back of the RP, just in case you don't have enough. And these are some of the associations that have that we looked at as far as procedures, and also that we kind of referenced in the RP. And basically, we just want to stop stop this from happening.
I guess one thing that I didn't hear discussed was the float chains in UDCs and testing of those. Was that a deliberate leaving out, or?
I'm sorry, one more time?
For the UDCs that don't have sensors, they have the float chain assembly that trips the shear valve.
For the ball and float?
Old Bravo boxes.
Oh, the ball and chain?
Close, yeah.
The reason why we didn't include those is because, yes, they are out there, but predominantly most of the systems that are not just in California, but also in the rest of the country, they're getting away from the shallow Bravo boxes and going with the deep UDCs. Again, if you go out there and that's what you have, then we recommend that you talk to the manufacturer to get the actual test procedures, because it should work the way it's designed. Okay, so the first two people to answer this question, the following question, will get a copy.
But you have to raise your hand first.
Okay.
Yeah.
Question. Name two associations in RP 1200 referenced for alternate vacuum testing of the interstitial space.
Do we see any hands?
Associations, I'm sorry, I thought you meant manufacturers. I was going to say Containment Solutions and Xerxes. But they're not associations.
What if they're wrong?
They still, you know what? Thank you for trying. Thank you for trying. And thank you for not cheating off of Corey.
It was Steel Tank Institute, publication R12, and fiberglass. Oh, I blew it. I'm sorry.
No, you didn't. You don't get one, though.
Oh, okay.
All right.
Okay, next question. What are the 3 ways to test a double wall spill bucket?
All right, I see a hand in the back. You want to shout it? Okay, fine. I ran over here for nothing then. Hydrostatic, vacuum. What are the 3 ways?
What if he's close to right? We have another gentleman over here.
Well, survey says, did he get 2 out of 3?
Yeah, he got 2 out of 3.
Does he deserve one?
Sure.
For trying? Okay, here you go. All right, we got another hand over here.
Hydrostatic, vacuum, and interstitial.
That's it. Hey, hey, hey.
New winner.
Okay, next question. Do the overfill requirements in Title 23 match the overfill requirements in 40 CFR Part 280?
Okay, see a hand here. She said no.
She's correct.
That's correct. Thank you.
I didn't see any other hands go up.
I saw her hand go up.
No, I didn't see any other hands go up.
Well, that's because she won. He's just waving at me now.
I kind of highlighted the differences between 40 CFR and Title 23, and that you have provided the addition in Title 23 is that you provide the restriction occurs at 95% of capacity. Does RP 1200 recommend that leak detector test equipment have an adjustable orifice?
Okay, Peter's hand.
I see 4 hands, 5 hands.
He said yes, it does.
That's correct. We got somebody else? Actually, we need to hold off on just...
Oh, yeah. Is that your opinion, or were you cheating? Okay, yes, you're right.
Okay. The answer is yes. We say that it should have an adjustable orifice. Next question, does RP 1200 recommend that the leak detector test equipment have a pressure regulator?
Hand up first.
Get him to write it down.
She said no.
Okay, next.
Okay. And this one, you say yes? This one says yes, incorrect.
It's no.
It's no. You still get one, though. The benefits of raising your hand. But now she'll know the right answer because she has it.
Question, where does RP 1200 recommend that the leak detector test equipment be installed to test an ALLD?
I don't see any hands. Are you guys thinking? Monica. Monica, I think you have one already, too.
Furthest, highest.
She said furthest and highest.
Okay, next.
Yeah, highest and the furthest, yeah.
Highest and furthest.
Huh?
Satellite,
Well, it's the highest and furthest.
yes? So it is highest and furthest?
Yep.
Okay.
Highest and furthest. Does the vapor shear valve need to be inspected in the UDC?
Okay.
Oh, there's a gentleman up against the wall that's been raising his hand 6 times. What do
Where?
you say, sir?
I don't
You
see
pick
him.
one, I got one.
Okay, where's yours?
He's over.
The one
I'm
against
sorry,
the
I
wall?
don't know your name, so I apologize.
Okay.
Yes.
He
Yes.
said yes. Okay.
Let me see, in RP 1200, what is the recommended vacuum level for testing the interstitial space of a 110% containment tank?
Maria. Maria. What was that? She says 6. Okay,
Next.
I see one more hand up over. Oh, she says 6.
6 inches. Yep, that is correct.
All right.
In RP 1200, what should the emergency stop switch remove power from?
Okay.
Who said everything?
He says everything. Do we have another answer? Right here?
I thought I heard 2 everythings coming from over there.
What was that? Everything's dispensers and turbine.
Yep.
Survey says?
And the survey says dispensers, STPs, and all associated. Is RP 1200 meant to supersede or interpret local, state, or federal regulations?
Socorro.
I got the gentleman over here in the plaid shirt saying no. Oh, that was the end.
That was it. No, we still have a couple more.
I'm not sure what happened
So
then.
these are like the final Jeopardy questions.